All right, perfect. Well, thanks everyone for joining us this afternoon. As I said earlier, I know it's a busy time in our industry right now, so I certainly appreciate any time that you guys are able to join us. We're excited today to have Kartik with us to give us an update on some of the work that he's been doing now over the last 2 years. At the University of Windsor regarding life cycle sustainability assessment of interior wall construction methods. This research is funded in part by MITACS, of course, Masonry Works, and CCMPA is providing funding as well. So it's kind of a combined effort across the industry. So I just wanted to make mention to all of the funding partners here, and I also wanted to just at the onset here kind of give a nod to the research team down at the University of Windsor, Dr. Rajeev and Kartik. Obviously, the challenges that have presented themselves through the COVID-19 pandemic have been unforeseeable, and I think that you guys, given the context of everything that's going on and limited access to the university resources, have done a fantastic job. So Kartik, I'll pass it over. I'm sure I see there's quite a few engineers on the call today, so I'm sure there's going to be a healthy discussion about the project. So I'll let you kind of figure out the logistics as to how you're going to handle questions or when you're going to handle questions. But given the fact that we're only about 7 or 8 people here, I think it would be good to have it more as an open discussion. So Kartik, at this point, I'll pass it over to you.
Sure. Thank you so much, Andrew. Firstly, I respectfully acknowledge that I am connecting to you from the traditional land of the Three Fire Confederacy. Myself, Kartik Patel. I am a PhD student, research assistant at the University of Windsor. I'm working under the supervision of Dr. Rajeev Ruparathna. He is assistant professor at the University of Windsor. This research is funded by Masonry Works, MITACS, and CCMPA. Uh, Today, I'm going to talk about one of this research that I'm doing with the MITACS. Uh, that's the life cycle sustainability assessment of interior wall construction methods. So, in today's presentation, I'm going to cover the background of this study area, the life cycle sustainability assessment, the objective of the study, methodology used for the study, result of the LCSA, and the conclusion. So let's start with the impacts of construction industry on the sustainable built-in environment in nowadays. So according to the United States Environmental Protection Agency stated in that report that despite the numerous benefit to the society, intense environmental and the social consequences are created throughout the life cycle building environment. Also, the in recent year, it shows in studies that the construction industry is the world's largest consumer of the natural resource. Also, the focusing on the social impacts are more important in a nowadays, as specifically if we talk about in Canadian context. The Canadians spends approximate 90% of their time within the building by being involved in indoor activities. So that will impact more in their physical and the mental health as well. Moreover, in only construction industry create like almost 23% air pollution, 50% of global warming impacts, and the landfill waste impacts, and the 40% of the drinking water pollution. If we talk about the economical aspect of this sustainability with the construction industry, uh, The total operation and energy expenditures of the industrial, commercial, and the institutional building exceed 24 billion Canadian dollar, which is approximately 3% of the Canadian GDP. Also, the U.S. Green Building Council stated in their report in 2009 that the construction industry responsible for 40% of energy users worldwide, with the estimations that by 2030 emission from the commercial building will grow by 1.8%. Also, nowadays, like, everybody is thinking about to consider their making based on the triple bottom line of the sustainability. So let's discuss what's the life cycle sustainability assessment. So basically, life cycle sustainability assessments refers to evaluation of all environmental, social, and economic negative as well as positive impacts in the decision making process towards more sustainable products throughout their life cycle. Uh, Also, why the life cycle sustainability is more important to consideration in nowadays. So if we see, it's considered the all three pillars of sustainability, as it include the social, environment, and economic aspects. It's provide more comprehensive and detailed comparison of the selected alternatives, and it's proven a more holistical approach in a decision making process. Moreover, the life cycle sustainability assessment supports decision maker in prioritizing the resource and investing them where there are more chances of positive impact than the least chances of the negative ones. Also, it supports the consumer in determining which products are not only the cost efficient, eco efficient, or socially responsible, but also the more sustainable. So fortunately, it help us to find out the weakness of the any of the product or processes throughout its whole life cycle, and one can enable to do some further improvements through the product life cycle. So that's why the life cycle sustainability assessment is important in nowadays. uh, Still it's facing some kind of challenges in industry because of the uncertainty of data, also the unawareness of the life cycle sustainability assessment. So these are the two major challenges that's facing right now this concept in industry. Let's start with the very first pillar of the life cycle sustainability assessment. That's the life cycle assessment. It's also referred as a life cycle environmental assessment. Uh, in a journal word, if we talk about the life cycle assessment, it is basically objective process that's evaluate the all impacts, all environmental impacts generated throughout any of the product or processes throughout its life. It's consist of the material extraction to its manufacture, transportation, utilization, reuse, and the disposal. Similarly, if we talk about the cost, the life cycle cost analysis is considered the different cost associated with the any of the product or processes throughout its life. Basically, it contains initial cost, service cost, maintenance cost, operation cost, disposal cost of the waste. So those are the different type of costs that associated with the different activity throughout the life of the any of the product or processes. Moreover, as I mentioned in the background, that the 90% of the time spent by Canadian in indoor activity, the social life cycle is also one of the most important aspect of this analysis. Again, the social life cycle assessment is considered the all the social impacts that's generated by any of the product or processes, uh, whether it's positive or the negative impacts on community throughout its life cycle. So also it provides a holistic and the systematic tool to understand the social issues that may arise in the value chain of product and services sustaining the human life today. uh, Next, I would like to jump directly to my study, that's basically on the interior walls. So for this study, I considered three different interior wall construction method that's available in like Canada. So for this research, I considered the steel stud gypsum wall, concrete block masonry wall, and the wood stud gypsum wall. The cross-sectional dimension considered for this walls is 3.2 meter into 3.2 meter. So based on the importance of the life cycle sustainability assessment and the impacts of construction in a sustainable built-in environment, I start my research with this overall objective that is to compare the interior wall construction alternatives based on the life cycle sustainability impacts. So to achieve this overall objective, I subdivided my objective into four different subcategories. The first one that's focused on the environmental life cycle impacts. The second sub-objective is to evaluate the economic life cycle impacts of three different walls. The third sub-objective is the social life cycle impacts of the three interior wall construction method, and the fourth sub-objective is to compare the all three interior wall alternatives based on the all three pillars of the sustainability. So the methodology that's selected for this research is based on ISO 14040 and the 44 that provides the all basic and necessary step for carry out the life cycle assessment. I also refer the ISO 15686 part 5 that gives me the detailed descriptions about the different cost associated with the life of the different products, and United Nations environmental program guidelines that helps me to carry out the social life cycle impact assessment. Basically, methodology follows four different steps. The first one is goal and scope definition. Second one is the inventory analysis. The third is the impact analysis, and the fourth one is the interpretation of the result. The impact analysis is carried out by for the different pillars of sustainability. I use the different software and the database. So for the life cycle environmental assessment, I use the eco invent database and beast method. And by using this database, I assess the environmental impact of the three interior wall types in Simapro software. I also used RSMin cost database to evaluate the economic impacts of the interior wall constructions. For the social life cycle assessment, I use the social hotspot database that helps me to carry out the social impacts generated throughout the life cycle of this interior walls. Basically, the social hotspots database aim to foster greater collaboration in improving the social conditions worldwide by the providing the data and the tool necessary for the improved visibility of the social hotspots in a product supply chain. So in general, it's divided the risk associated with the social indicators in the four different risk category: very high risk, medium risk, and low risk. And based on the weighting factor, they provide us the results. Let's start with the first step of the life cycle sustainability analysis. That's the goal and scope definition. So, as I mentioned earlier, the objective of or the goal of this research is to analyze the life cycle sustainability impact of the interior wall construction alternatives. For this study, I used the functional unit as a 3.2 meter into 3.2 meter. That's the cross sectional dimension of the wall. The system boundary used for this study is the cradle to grave. That consists of the material, raw material extractions to the end of life of the material. I also consider the reusability of the waste material in this analysis. The study period considered as a 40-year. That's based on the literature values. I also used bees method to assess the impact of the environmental and the economic aspect of the sustainability. The next step of this analysis is the inventory analysis. As this table shows the three different wall interior wall construction methods, and that details about the layer distribution, the dimension that I consider for the analysis, different material used for the wall construction, also for the environmental impact analysis. I considered two assumptions. The first one is the like the gypsum board and the stone wool that is totally considered as a waste material, and at the end of its life, it's directly go to the sanitary landfill. And 95% of the waste generated from the concrete block walls that's reused in the other concrete construction work and the roads upgrade after its end of life. So also for the life cycle cost analysis, I consider this inventory data. uh, for the life cycle cost analysis, the life of wall is varied as because the durability of the concrete masonry block walls are quite higher than the steel stud and the wood stud gypsum wall. We are facing several issues with like uncertainties with the life of wall and the maintenance activities. The cost data that is used based on the RS means cost database. Also for the life cycle cost analysis, I consider the 95% of the material, concrete block material reused after its end of life. The next step is the life cycle and a life cycle assessment result. So this table elaborate the 13 different environmental indicators and that characterize results based on the three different interior wall construction method. Based on this LCA results, it shows that the natural resource depletion, smog generation, and eutrophications are the three major indicators that are affected through this kind of construction activities. Uh, Also, it shows that at the cradle to grave boundary conditions, the concrete block masonry walls comes as a more environmental friendly options than the steel stud and the wood stud gypsum wall because of the reusability of the waste concrete material after the end of its life. The next result is the life cycle cost assessment results. Life cycle cost is evaluated by using this formula. It consists of the different costs associated throughout the life cycle of the interior walls. I consider initial cost, maintenance cost, demolition cost, and also use the salvage value and the salvage value to find out the life cycle cost of this interior walls. The result indicates that the at the cradle to grave boundary condition, concrete block walls perform more better, and it's proven a more economic options than the steel stud and wood stud gypsum wall because of the maintenance activities. For this study, I only considered the painting as a maintenance activity. However, the work is still going on in the life cycle cost analysis, and I already flowed the questionnaire survey in the industry to find out the more maintenance activity associated with interior wall construction. So the result will be validated after the life cycle costing questionnaire survey data. The next results are the social life cycle impact assessment results. The result is you can see the results of the 25 different subcategories of the social indicators, and the result are provided in median working hours. Uh, for more easier way to elaborate those results, those 25 different subcategories are separated in the five major categories. That's the labor right and decent work, health and safety, human right, governance, and the community. The result in this graph shows in the points or the score value. This score value is generated after normalize those characterized results, and multiplying those results with the weighted factor, and the graph is generated in the point values, so for easy comparison. The next one is the fourth sub-objective of this analysis. That's the life cycle sustainability assessment result. So here I compare the three interior wall construction alternatives by all three pillars of sustainability, and I use normalized score value to assess these alternatives. So this graph shows that the concrete block wall comes as a more sustainable alternative amongst from the selected three alternatives. If we talk about the environmental impacts, we can see that is impacts point 2, where we can see the steel stud impacts more, or we can say it's poorly perform in environmental indicators. It's almost impacts point 47, while the wood stud is uh, comes the second, as it's create 0.32%, 0.32 impact on the environmental category. If we talk about the social and economic indicators, the steel stud and the wood stud proves almost similar, with the steel stud with a 0.33 and the wood stud gypsum wall with the 0.32 normalized score. Based on this evaluation and the results, uh, the life cycle analysis or the environmental impact assessment shows that the concrete block masonry walls impacts 49% and 21% lesser than the steel and wood stud gypsum wall. If we talk about the life cycle cost of concrete block masonry walls is almost 23% and 20% lesser than the steel and the wood stud gypsum wall respectively. And if we consider the social impacts of the wall alternatives, concrete block walls perform uh, uh, well in the social indicators as well, and it's create 18% and 15% lesser impact than the steel and wood stirred gypsum wall. So based on this result, I concluded my study that the steel stirred gypsum wall perform poorly in all three sustainability aspects, while the concrete block masonry walls comes as the more sustainable alternative uh, as it's provide like more sustainable in all three pillars of the sustainability. This research has one publication that's focused on only the life cycle assessment part, that's focused on the only environmental impacts of the interior wall construction, and it's presented in the this year's CSC 2021 conference. The research is still ongoing. The questionnaire, as I mentioned in the life cycle cost analysis part, the questionnaire survey is currently underway. So I'm working on that part. Also, the long-term physical condition assessment of the interior wall is also, I'm trying to start working with this part for this study. I like to acknowledge Mr. Andrew Penny and the Dr. Mark Hagel for all their supports, their feedbacks. That helps me a lot to improve my work. I also like to acknowledge Machinery Work, Canadian Concrete Machinery Producer Association, and the MITACS for funding this research, and my supervisor, Dr. Rajeev Ruparathna, for providing me guidance throughout this whole study. So thank you so much. And here I put some my and Dr. Rupratna's contact information. So you guys can contact us if you have any question relevant to this study. So thank you so much.
Awesome. Thank you, Kartik. I guess at this point we can open it up to any questions here. I know the study has been ongoing now for about 2 years, and
Mhm.
I'm quite happy with the results. And I think
Thank you. Yeah.
coming from the block sector, I think there's a lot of good material here that will be increasingly more important as the users of block masonry become more more subject to policy in so far that they will be having to address the climate crisis. So
Yeah.
with that, I will open it up to the floor here if anybody has any questions. Just got a comment in the chat box here. It's fantastic work. So
Thank you so
um,
much.
seems like a
Mhm.
quiet crowd um, this afternoon. Is there anything from anybody out there? Okay, well, with that,
Andrew,
oh
let me, like, let me ask a question from Kartik. Maybe this is something that can further elaborate on certain things that we did in this research.
Of
For
course.
example, now we have used social life cycle assessment. Maybe Kartik can elaborate on that part, because that's something that has not been considered in many life cycle assessments. But since we were able to get access to some updated databases, we were able to perform that. So can you explain a bit more about social life cycle assessment that you did, Kartik?
Yes, sir, definitely. So, as Dr. Rupratna just said, and even I referred the many literatures that perform the life cycle assessment, but the social impact is always like considered as like some of the literatures consider the social impact, but not the way that actually required to focus on the social aspects. Uh, So, in a context of the social life cycle assessment, uh, here I used social hotspots database. Let me, okay. So, so that's the database that like provide a very wide range of the data. It provides the country specific data for each and every country. So for this research, I considered the Canadian context database and perform my evaluation. Uh, this research is also like provides the uh, assessment in like a median working hours. So that consists of the risk and the wage required for the each 25 subcategories of the social impacts, and to elaborate those results in more clear way. They provide the normalized result, weighted result, and the point-based result. So we can easily, if the person is not familiar with that aspects of the evaluation, they can easily understand what's the result try to indicate. So the social life cycle is that uh, I used that what I used in this analysis, the social hotspot database, and yeah, and I think that's the uh, major impact category, similar to the environmental and the economic as well, because there are lots of subcategories. We can see that the wages, or the we can see the accessibility of the resources. So those are the major factors that still people are not considering in the research activities, but that's highly impact on the community. So yeah, this is what,
Thank you, Kartik.
yeah.
And what about the cost data that you have used? Because again, cost data can vary significantly based on the region as well as based on the time. So,
Yes, sir. So for that, I would like to say that the cost data is like vary with the regions and time to time. So there are the several uncertainty associated with the life cycle cost. So to overcome that kind of uncertainty, I used the Atrix software, and I performed the uncertainty analysis for the life cycle cost. And based on that uncertainty analysis, I found the or I've calculated the life cycle cost of the three interior wall construction.
So I think that's kind of touching on the question that's in the chat box. I believe it is the life cycle cost assessment. Was painting the only maintenance required of the block in the 7 to 10 year life cycle?
Uh, okay, yeah. So as I mentioned that in this study, I just considered the painting as a maintenance activity, because that's the only thing I can able to found from the literatures that gives me the year ranges. There are other different maintenance activities, uh, like the condensation issues, the water leakage issues in the interior wall. So those kind of things also impact on the life cycle cost, because it's required there are several kind of maintenance work. But those things are not fixed; those are uncertain. So So to find out the more detailed supportive literature work, or more detailed support for those kind of calculation, I already float the questionnaire survey in the industry. So based on the result that I will get from those questionnaire survey, that will help me to find out the what kind of other maintenance activities that still need to be considered in this evaluation, and that help me to like validate my result of the life cycle cost. So yeah, that's the work is still ongoing for this study. So
Perfect. And I know that the survey is now floating around. So if you do see the survey come through your inbox from Kartik or myself, be sure to pass it on
sure.
and complete it if you have um, any building management or life cycle or asset management experience. So, all right. So in the life cycle cost assessment, what type of maintenance was required for the gypsum walls in the 5 to 10 year life cycle? Was that also just painting considered, or was that also considering holes and such in the walls?
uh, for the like steel and
Yeah.
the wood stud gypsum wall, there are other things that's because those kind of walls like affect very easily, like the usage of the person is also impact on those kind of wall. So but those things are uncertain for the evaluation. So I already consider all those things in a questionnaire survey as well, that will help me to build a more supportive document for this life cycle cost. So yeah, but here I consider paint for all three types of wall as a
Perfect.
maintenance activity. Yeah.
Okay. Is there any other questions out there? Otherwise, we can end this afternoon's webinar. Anyone else quickly before we go? Okay. Well, thanks everyone for joining us this afternoon. Kartik, thank you for your time, and
Thank
Dr.
you so much,
Always, it's
Andrew.
great to have you guys on. Again, I'd like to thank the funding partners on this project, CCMPA and MITACS as well. So obviously, this wouldn't be getting done without the support from those two organizations. So I'd just like to underscore the contribution that they are making to this project. So I hope that everybody has a good afternoon, and I hope
You too.
that you'll be able to use this information as we work through this, and as Kartik provides us with more detail and context here. We will be coming up with a communication strategy for this for the industry as well to push out. So keep your eyes open for that, and we look forward to continuing this work and seeing the results of the questionnaire, and obviously the long-term physical condition assessment as well. I think it's really good work. So thank you, everyone, and I hope everyone has a good afternoon.
Thank you so much, Andrew. You too.
Thank you, Andrew, and thank you, everyone. Thank you for your
Yes.
support.
Thank you so much.